want to give you some help answering this last question. It's going to be pretty tough. In this question, you're asked to imagine that the hanging weight was not 0.36, or I think for some groups it was 0.35, the hanging weight. Look, you can look that up. But imagine it wasn't that, but 600 grams, which of course is 0.600 kg. The sliding block, I think it was 0.27. You can look that up as well. So now you're asked to find the acceleration of the system, but you should know that we're going to keep the coefficient of friction that we found. I don't know, what was it, 0.52 or something like that. I'm going to make it up and you could just look up the actual one. Don't use 0.52, that's not it. So how do you find the acceleration? With Newton's second law, that the sum of the forces over the mass is the acceleration, because that comes from F equals ma. What's the positive force? Well, you've got the hanging weight that we're asked to imagine is not what we use, but 0.60 kg. That's going to provide a force. That's a positive force, but the negative force is the friction. That's mu mg. Now, you're going to use our mu. I don't really know what it is, 0.52-ish right in there. Use the sliding block, because that's what gets the friction, and we use 9.8 for the g. All of that gets divided by both masses, both the 0.36, if that's, or 0.365, I don't know, or 0.36 or 0.35, I'm not sure what it is. It might be in something entirely different, but you'll use that. Now here's the new hanging block, and there, that's 0.98 rather, you'll get a certain answer. What's the velocity? Well, once we know the acceleration, you'll have that. You know the distance, and what was the distance? Look up on this table over here. I'm going to show you. We've written down the distance that the thing falls. It's right over on this page over here. You'll find the distance. Right here, the drop height. Use that drop height as your distance to find the velocity just before it's the ground. So that's going to be your d. I don't know, is it 0.7-ish, 0.8-ish, something like that. You'll have that. And you want the, the initial velocity is 0, and what you want is the VF. And so we'll use VF squared equals VI squared plus 2AD. So you've got this from the question above. You have this from the table. Everybody's VI equals 0, and then you solve. What's the kinetic energy of the block just before it's the ground? Well, this is the equation for the kinetic energy. 1/2 mv squared. And so you've got to look up the block's mass on the sliding tail. I think it's 0.27. Maybe I'm wrong. The velocity you just found up here, and so that's the kinetic energy. Easy enough. Now, what's the sliding distance? Well, what stopped the sliding block is friction, the work of friction, which is the friction force times distance, and equals the change in KE, and that's just going to be this value over here. You'll bring it down. What's the friction? Mu, like I said, I think it's 0.52-ish. 0.52 times mg, that's how you find the friction. What m do you use? The sliding block, which I think might be 0.27. You can check me out on that. So then you find the friction over here, put it over here. You don't know this, and this you get from above. I hope that helped you, and that's all I got.